for Elimination Day 2. There is no essential question for this lesson. Alright, our first example, we're going to use elimination to solve the system of equations. So we need to ask ourselves, how could we create opposites in this system? Well, let's look at our x's. We have 6x and 3x. 3x can go evenly into 6x, so that is a possibility. Let's look at our y's. 2 can't go into evenly to 7. 2, 4, 6, 8. So that's not going to work. So that means we have to work with this bottom equation and try to eliminate our x's. So if I have 6x, the opposite of 6x would be negative 6x. 6 and negative 6 would make 0. So I have to ask myself, what do I have to multiply 3 by to get negative 6? Well, I know 3 times 2 gets me 6, so 3 times negative 2 would get me negative 6. So I'm going to times every number by negative 2. I'm going to X out the equation that I'm not using anymore, which is my middle one. And now I'm going to look and make sure I made opposites. 6x and negative 6x make 0. So yes, I made opposites. So now I'm going to take this negative 2y and 14y, and that gives me 12y. And I'm going to take this 10 and this 38, which gives me 48. Divide both sides by 12, and I'm left with y equals 4. Now remember, I'm only halfway done. I have to take that 4, and I usually like to plug it into the top equation. Make sure you plug it in for y. So 6x minus 2 times 4 equals 10, and then I'll just do couple and third wheel. Add 8 to both sides. Divide both sides by 6, and I'm left with 3. So my coordinate point where this system would intersect is 3, 4. Next example, we have 4x plus 2y equals 8, 3x plus 3y equals 9. Now we'll notice with this system in a second here, let's look at the x's. 3 can't go into 4 evenly. 2 can't go into 3 evenly. So we're going to have to multiply both equations in order to make opposites. So this one is a little bit different. So let's ask ourselves, what is the lowest number in common between 4 and 3? Well, 4, 8, 12, 16, 3, 6, 9, 12, 15. My lowest number in common between the two was 12. That is one possibility. I could use the number 12. Or, how about let's do it for 2 and 3. 2, 4, 6, 8, 10, 3, 6, 9, 12, 15. The lowest number in common between 2 and 3 is 6. So you can really choose whichever one you want to. It doesn't matter. I like to choose the smaller one, so I'm going to choose the 6. So I want to make my top equation become 6. So that means I have to multiply 2 by 3. And then I want to make my bottom equation become negative 6. So that means I have to multiply 3 by negative 2. So both of your equations are going to be changing. So let's start with the top one. 3 times 4, so doing this right here, is 12x. 3 times 2 is 6y. 8 times 3 is 24. So now we're done with that one. Now we'll go to this one. Negative 2 times 3 is negative 6. 3 times negative 2 is negative 6. 9 times negative 2 is negative 18. Now I'm done with that one, so I'll cross that one off. Now, if you did this correctly, you should have made opposites. 6 and negative 6 make 0, so we did. 12 minus 6 is 6. 24 minus 18 is 6. Divide both sides by 6, and you get 1. Now I'll take that and plug it into my top equation. You can use any of the 4 equations. You have 4 possibilities now. I'll still do the top one. 4 times 1 plus 2y equals 8. 4 plus 2y equals 8. Couple and third wheel. Minus 4 on both sides. 2y equals 4. Divide both sides by 2, and we are left with y equals 2. So my coordinate point for this system is 1, 2. All right, now we have 6x plus 2y equals 2. 4x plus 3y equals 8. Well, we know from the last example, the lowest number in common between 2 and 3 was 6. Let's do the same thing for 6 and 4, just so we can get a little practice. 6, 12, 18, 24, 4, 8, 12, 16. So my lowest number in common between 6 and 4 is. So again, I like to choose the smaller number, which would be the 6. So I'm going to times both equations. One of them needs to end up with 6, one needs to end up with negative 6. So I'll multiply the 2 right here. We'll multiply that by 3 to get 6. And we'll multiply this 3 by negative 2 to get negative 6. So I'll start with the top equation. 3 times 6 is 18. 3 times 2 is 6. 3 times 2 is 6. Cross that one off, then the bottom one. Negative 2 times 4 is negative 8. 3 times negative 2 is negative 6. 8 times negative 2 is negative 16. Cross that one off. Now I know I did this correctly if I made opposites, which I did. 6 and negative 6. 18 minus 8 is 10. 6 minus 16 is negative 10. Divide both sides by 10. I'm left with x equals negative 1. Take that negative 1 and I'll plug it into my top equation. So 6 times negative 1 plus 2y equals 2. Negative 6 plus 2y equals 2. Add 6 to both sides. Divide both sides by 2. And we're left with y equals 4. So the coordinate point for this system, the solution is negative 1, 4. Alright, the directions for this problem say set up the system of equations. So it does not say solve, it just says set up. So the cost of 2 groups going to an amusement park is shown in the table. So we have our 2 groups that are going. We'll say Group A and Group B. Group A has 4 adults and 2 children going, which is going to cost them $184. Group B has 4 adults, 3 children going, which is going to cost them $200. So what we're trying to figure out when we set up this equation is how much is an adult ticket, how much is a children's ticket. We want to know how much we're paying for each ticket. So we're going to set up one equation for Group A, one equation for Group B. So if I have 4 adults going, plus my 2 children going, I know that that's going to cost me $184. Now the only thing that I'm missing from this problem is variables. So we're buying 4 adult tickets. We don't know the price, but it's 4 tickets times the times the cost of an adult, plus 2 children times the cost of a child. So there is our first equation. And if I do the second thing for the bottom, I have 4 adults and 3 children this time for a total of 200. 4 adults, we don't know what the price is. 3 children, we don't know what the price is. So we have set up a system of equations right here. We could solve it if we wanted to, but this is just asking you to set up the system. So that is how you set up the system. The homework for this lesson is page 358, numbers 11 through 16 and 27.